What do you think, guys? Is this a general motion, or this is a uniform motion, or this is a uniformly accelerated motion, and why? Uniformly accelerated motion. In fact, this is a uniformly decelerated motion. But yes, it is a uniformly accelerated motion. Why? Why this is a uniformly accelerated motion or decelerated motion? Because A is constant. And the only force acting on it is its weight. Yes, in fact, guys, A is constant and it is equal to what? To the gravity. A is equal to 9.8. Positive or negative 9.8? Yes, Sana, it is negative 9.8. Why A is a negative 9.8? So why A is a negative 9.8? Yes, it is decelerating, but it's not what I want you to say. Yes, because it is opposite to our chosen positive axis, guys. Perfect. If I choose from the very beginning of this problem S positive in the downward direction, then A will be positive. All right, guys? If I choose S positive in the downward direction, A will be positive. So A is negative because it is in the opposite direction of the positive S. So guys, this is a uniformly decelerated motion where A is constant and it is equal to minus 9.8. How to start? How to solve for SB? So how to solve for SB, guys? What do you think? What is the equation that should be used in order to find SB? The one independent of t. Perfect, Noor. Yes, last one, Radwan. Perfect. So it is the equation that is independent of t because I don't have any t here, right? So the equation states that VB squared is equal to VA squared plus 2A constant. This is not AC, all right? I mean by AC, A constant. TB, I should start by B because this is VB, minus TA, right? Which means, guys, that VB, which is 0 here, is equal to VA, which is 75. Sorry, you're right. This is SB. Oh, okay, it's SB minus SA. Now, VA is 75. AC is negative and it's equal to minus 9.8. SA is known, it is 40, and I'm gonna find SB, and this means, guys, that SB will be equal to what? To 75 squared over 2 times 9.81 plus 40, right? So I think that this SB will be around 337 meters. Guys, what you have to know about the unit here, this is SI unit. The velocity is in meters per second. The length or the position should be in meters, all right? So the position should be in meters. If it was in millimeters, I should convert it to meters, and the acceleration will be in meters per second squared, all right? Jad is asking, how did we get this formula? This is the formula, Jad. This is from ADS is equal to VdV. After doing the integration, we found the independent formula of time. So since it is independent of time, I can do it between any 2 points B and A that belong to the path of a uniformly accelerated motion. All right? So that's it. This is the equation. Okay, so this is SB. Now, I should find VC. How can I find VC, guys? What equation should I use? How can I find VC? The same equation, perfect, because it's also independent of time. So guys, I'm gonna find VC using the same equation. Now this equation could be applied between A and C or between B and C. It's up to you. Now, if you're not sure about your answer here, so you're not sure about SB, you can apply it between A and C. If you are sure about SB, like my case here, this is meter, of course, all right? I can apply it between B and C because it's much easier. VB is equal to 0, all right? So I'm gonna say that VC squared is equal to VB squared, which is 0, minus 2 times 9.81 SC, which is also 0. So 0 minus SB. Now what is SB? SB is 337. All right? So guys, VC squared is always positive. You should have a positive answer here. So minus minus is positive. All right? Now this VC squared, if you do the calculation, it will be around 6,400. All right? So this V squared will be around 6,415. If I need to find VC, I should take the negative root because it is the opposite direction of the positive S. So you should take the negative root, right? So VC will be equal to minus 81, I think. Yes, 80.1. Minus 80.1 meters per second. All right, guys, do you have any question on this problem? AC is the acceleration between A and B. Jad, AC is constant. It is the same all over the path. It is equal to the gravity. Now, since this S, positive axis of S is upward, then AC means the constant acceleration. It's all over the path. This A constant will be equal to minus 9.8 because in fact it's equal to the gravity, and since it is downward and the positive S is upward, then it should be negative. Okay? So I cannot say that this is the acceleration between A and B. It's the acceleration all over the path between A to C. This is a uniformly decelerated motion. Any other question? Doctor, when the rocket is falling from B to C, isn't a free fall, so accelerated, so why negative? The same answer. Yes, it is a free fall, but I specified my positive direction to be upward in S positive upward, all right? So since A is downward, then it should be negative. Now, Hassan, if you take the positive S downward, then A will be positive. Okay, if you take from the very start of this problem, SA, let's say if you take B as your origin, correct, and SA is positive downward, then A will be positive. Okay, but since I took this S positive in the upward direction, then you should stick to this positive axis all over the problem. Since A is downward, then A is negative. Okay, Hassan? Don't be confused. I know that A is equal to gravity. Okay? So I know that A is equal to gravity. And I know that since the gravity is 9.81, then A should be 9.81. But in fact, even the gravity is in the negative direction with respect to S. S is positive upward. All right? So since S is positive upward, then the gravity is 9.81, and then A is equal to minus 9. Then the gravity is minus 9.81, and then A is equal to minus 9.81. Okay, guys? Noor, is this still considered decelerated even if V is increasing? V is not increasing from B to C, Noor. V is decreasing. It is decreasing from 0 to minus 80.1. This is the velocity. I'm talking about the velocity, not the speed. It is not the magnitude of the velocity. I'm talking about this velocity. It is increasing in the absolute value, but it is decreasing in the scalar or the algebraic value. So B is going from B to C, from 0 to minus 8.2.